right? So now the class is officially being recorded, and we'll start with the solved problem. And it reads as follows. Marty Schatz owns and manages a chili dog soft drink near the campus. Although Marty can service 30 customers per hour on average. Whenever you are servicing something, as you know from the formulas, you are saying this is a symbol of servicing, so that is 30 customers. So the units are important in this case. It's 30 units that you are able to service per hour. Then there are questions whereby this is not stated in this manner. You're starting with hours and then units. You need to be able to convert. At times you have seconds, at times you have minutes, at times you have whatever that you can have. You should be able to convert. He only gets 20 customers per hour because Marty could wait 50% more customers, could wait on 50% more customers than the actual visit. It doesn't make sense to him that he should have any waiting lines. Marty hires you to examine the situation and determine the characteristics of his queue. Okay, so also it is very critical that you understand each and everything that you are looking for and you understand its units. Okay, so now we're gonna go to the first formula. It says the number of units or customers in the system, right? Because I know you don't have the formulas and your studying will be difficult if I don't do this. I would rather write the formula still. And 20 customers per hour over 30 minus 20 equals, you can almost tell that this is 20 over 10. I want to see if I can bring my calculator because I'm working from home. Let's see. This one. I don't have mine. This. Okay. How you on statistic? Shift that. What am I using? Okay. So now we have 20 divided by 30 minus 20 equals to 2, right? So 2 customers are in the system. 2 customers are in the system per hour. Then we have how long does the customer spend in the system, or how long does the customer takes in the system. Then that is 1 over that minus this, which is 1 over 30 minus 20. You can leave it like this. I sometimes prefer them like this in case I need to use them later. I leave them like that as a fraction. Then we have the customers on the queue now. Customers that are on the queue. IT. I need to answer this, guys. Hello? Morning. Okay, so I would like to see you at let's say 10:30. I'm in an online class now. Then immediately after that, I'll come to campus. Yeah, after. Yes, thank you so much. Thank you. Cheers. Bye. Okay. So the number of customers on the queue is as follows. You got your formula. Just repeat the correct formula. I need to reply to something important here. Okay. Which is going to be 20 squared over 30. 30 minus 20, which is going to be 20 squared over 30 bracket 30 minus 20 equals to 4 over 3. Right, then moving right along, we have waiting, the average time for waiting in the line. There is average time spent in the line, and there is average time spent waiting. So this is the average time for weighting. As you can see, the formulas don't really get spicy. They are as they are. But you know that when we are writing, our brothers and sisters will choose their own formulas instead of the ones that we are using. Let me put away my calculator. I keep on taking it and wanting to calculate. I'm not used to using this one. Why can't I edit? Yeah. 1/15, right? Then the probability at times I would say to you a percentage probability, then you multiply by 100 and then you'll get this thing as a percentage form, which is 20/30. I believe that is 2/3. 2/3, which is 2/3. When you multiply it by 100, you're gonna get 2 divided by 3 equals to that. No, what am I doing? 2 divided by 3. Here in the 2/3 there, multiplied by 100, you're gonna get 67%. 66.7%. So it depends on how they are asking this question. Right. Then P0, the probability that there won't be anything, any product in the system or customer. It's going to be 1 minus 2/3. Then that becomes 1/3. Okay, that becomes 1/3. Then another person would ask, then what will be our P? This one, it is always given. The question will always be given on how to tackle the probability that of greater than K, probability of greater than customers on the line. It will always be given. So then they would say something probability that we have more than 2 customers. And then in that case we have P, and I've seen that in the book they always skip 0. They just go straight to 1 and then equals to 20. Let me erase. Okay, something I don't like here. The eraser's too far from. Erase, move. The pen must be next to the eraser. There's no way. Yeah, at least like that. No, come outside. Okay, whatever. Sticks irritating me. I don't want to use this other fancy pen of theirs. It doesn't allow me. 20/30, which is going to be 1 plus 1 equals to And then sometimes they want it in a percentage form. So you multiply by, actually, yeah, they always want it in a percentage form. You multiply by 100. So it's going to be open bracket that 20 going down to 30, then up 1 plus 1 is equals to times 100 is equals to 44%, 44. Then where Pn is greater or equals to 2, we have this as 20, 30. This is going to be 2 plus 1 multiplied by 100, of course. Then so the best is to edit times 100. Then that is 29%. 29% of the time means that there's going to be more than 2 customers. This is what it means basically. Rofua, you can speak.
Can I ask you, how do you know Uguti when you are inserting the key values? How do you know ukuthi kwamele ugcine ku-2?
Aha, good. They will tell you in the question. That's why I was saying that in this case, we would say, what is the probability that we have more than 2 customers in the system? You see, the way I'm putting it exactly with my words, it's exactly that how we're gonna see it in the next section where we'll be doing the actual book problems. Because remember, the inspiration comes from there. The inspiration for the test comes from there.
Also, if they said ukuthi what is the probability kube bebathe 5 customs replace okay value up until ku-5.
I feel it until 5. Yes, until 5.
Okay, thank you.
Sure.
Sir,
Yebo.
can you please get back to the question just like few seconds? I want to confirm something with you.
All right. Here or the test, the statement itself.
Yes, sir. Yeah.
Okay.
So, sir, just like let's start at Mentine. Let's say Menti could wait on 50% more than customers than actually visit the store. Then, sir, that 50%, I want to understand, is not the utilization or what, the probability utilization.
No, it's not. It's something that maybe they want to benchmark with, and when you do these calculations, you will be able to benchmark with it. So let's say, for instance, when you look at the probability, the one that we got, I don't think it's even the probability is 66%. You see, so we have a probability that will be servicing a probability of 66% that will be servicing these customers. So you do not look at the effect of the other statements that you've written. Basically, you stick. So far, all the questions has never been affected by any additional information that was written there. So even if you go to their answers, their book answers, as you can see, two looked for L, W, L, Q, then waiting on the queue, probability of, you see here, percentage of time. This is what I like also. Percentage of time that Marty is busy waiting on customers, and then probability that there are no customers in the system. So this also actually, I thought that it's supposed to be you servicing the customer, but seems like it's probability of you waiting on the customers. And also, it's very critical that you understand whatever that you are doing. This W, it says time. So you need to be able to say hour once you're done. Here it says customers. You need to be able to pinpoint that you are dealing with customers. Whenever you're dealing with probabilities, you do the probabilities. Whenever you're dealing with the hour, you speak about the hours. So your SI units really matters. Make it a point that that part you appreciate it when you are practicing for your test. Right. So now this section, it says refer to solve problem. Okay. Marty agreed that these figures seem to represent his approximate business situation. You are quite surprised at the length of the lines and elicit from him an estimated value of the customer's waiting time in the queue not being waited on at 10% per minute. So you see now, they're talking about per minute, and another time we are talking about per hour. So it's very critical that you appreciate whenever the times are changing. So that's 10% per minute. So you can almost write it down, 1 cent. Oh, so when you make it, you know that it takes how many cents to make $1? It takes 100. So 10 divided by it becomes per dollar, and then obviously per minute. Okay, that's the value that they're talking about. It's the cost of waiting, cost of waiting, and then during the 12 hour, he gets 240 customers. in a 12-hour shift, and then the average customer in his queue is 4 per minute. Okay, so the total customer waiting time is 960 minutes. So if this is customers and their total waiting time is 96 minutes, so that's going to be a W like that. Waiting on the queue, yeah, waiting on the queue. So you need to know where they're waiting, in the system or in the queue. Okay, so now obviously there is this issue of 0.1 times that total time of waiting, but it's not enough. You still need to multiply the 20. You can tell Matty not only is 10% per minute quite conservative, but he could probably save most of that 96 of customer ill if he hired another sales clerk. After much haggling, Marty agrees to provide you with all the chili dogs you can get during a week-long period exchange. Okay. With customers, assume that Marty hires one additional sales whose service rate equals to Marty. Compute the analysis. So I wouldn't ask you such a vague uh, question in a test whereby it doesn't stipulate what you must be looking for. I would definitely make it a point that you know what is it that you are calculating at any given moment. So one of the things that I do not like asking is I wouldn't want to ask a question that requires you to break down your, because if you look at this is we have a formula that says, so if you look at that, they did away with that, the rate at which customers are coming, and they only focused on on this. I don't appreciate having such questions because I know you, in reality you would find yourself working around them, but I prefer a complete one whereby I ask you the total cost where you are required to have the service cost. This is what I prefer to ask whenever I set the test. Okay, so now we okay. So without wasting any time, it is best that we just go to the book problems. Because here you'll have to redo all the calculations, uh, looking at the two systems. Then after that you find the answers, because you cannot obviously do the cost without having this. And obviously, if you are looking for that and you look at the formula, what it requires from you, you'll have to calculate everything that is there. So yeah, but if people want us to go that route, we can recalculate all these things uh, because obviously they want to do it for study purposes. What should we do? Should we just go straight to the class problems?
So let's go
Guys,
straight to the book problems.
thank you so much. Yeah. Okay. So as you can see, this also doesn't ask you specific questions. So I would be asking you the similar ones as this. So this is a type of, so I'll break it down like this in this case. So, but let's just do this one and see how far do we go with it. It says that what is it? Whatever, Shemley discount department store has approximately 300 customers shopping in store between 9 and 5. Ne? So if you look at 9 and 5, you have an 8-hour period between there. Ne? So there are 300 customers, even without knowing what is happening here, by just looking at the situation, you should be able to say you are having 300 customers per 8-hour shift. Therefore, that could easily be 300 divided by 8. Okay, then you have approximately 37.5 customers in the store per hour. Ne? And then on Saturdays, in deciding how many cash registers to keep open each Saturday, Shemley manager considered two factors: customer waiting time and the associated waiting cost, and the service cost of employing additional check clerks. So now you have your service cost. It's equals to 8 per hour, and then checkout clerks are okay. Sorry, yeah, 8 per hour, and then when only one is on duty, the wait time per customer is 10 minutes. Okay, so let's say maybe the WK is 10 minutes, which is 1/6 hour. Okay, when there are two clerks now, we have 4 minutes. Now it's going back to minutes. So you need to be able to say, okay, so that is 4 minutes when there are 3. How do I write this? Okay, that is 4. The waiting time, 4 minutes. Okay, we want to say waiting time is in hours. Okay, all right. Then to solve that quickly, rather you fix it now. That is divide by 60 equals 4 divided by 60. We are going for hours, and then it becomes 1/15. Okay, then when 3 clerks are working, so when there's 4, this is 1, 4. When there are 3, oh, this is 3. And then when there are 3 minutes, when there are 4 clerks, okay, 3. When there are 4 clerks, you are doing 3 minutes, okay? 3/60 equals to. Even this one is a vague question, but it's fine. Just do it either way. 20, right? So Shemley management has conducted a customer customer satisfaction surveys and has been able to estimate that store suffers approximately, so that is the WCW, approximately $10 lost and goodwill for every hour of customer time spent on waiting check lines. Yeah? Using the information provided, determine the optimal number of clerks to have on duty each Saturday minimizes the total expected cost. So now the nice thing is we are given this. We are given the waiting time, and I believe this we can take it as our customer arrival per hour. Okay, so now then this becomes total cost 1 when there's 1 customer, and then that is, the formula that we just covered now, MCS plus this CW WQ. So this is going to be our formula. So when there's one customer, one click, so this is becomes one this side, and you have what is your service cost? It's 8 times how many hours? 8 hours plus 37 customers times CW, that is 10, times WQ, that is WQ, that's your waiting time, which is 1/6. 1/6 multiplied by the overall working hours. Then you do this for total cost to when they are actually how many clerks when they are, what do they say, the duty average checkout, 2 clerks on duty, okay, and that is 6 minutes, okay. Okay, we have 4 minutes there.
Say, sorry man, on our substitute, the first is for the total number of working hours.
Okay.
On our substitution, the 8 times 8.
Yes,
Can you hear me, sir?
I can hear you.
I was checking if about okay, the first 8 is for the number of hours that they are working per day on the. So what about the last
Yeah,
8 there?
that's $8. Actually, remember this is number of clicks here, which is 1 multiplied by the cost, which is $8 per hour, multiplied by how long are they working for the day, which is 8 hours. So ultimately, this is like saying 1 multiplied by 1 click multiplied by his cost multiplied by the number of hours, because he works for 8 hours. And that's why even here we did add that 8 hours. You must always add it, otherwise your cost will be per hour, and you don't want per hour, you want for the whole day.
Okay, I now understand. Thanks.
Sure. I believe, mathematically speaking, we can say if we remove this 8, we remove it this side, isn't it going to be the same thing as this, whereby you just at the end say, oh, okay, if I do this for an hour, then now I want to see for the whole day, then you'll be leaving it like that. Multiply by 8. I believe we should be able to find the same answer. I believe we should be able to find the same answer. So now we do for whenever you have 2 clicks. 2 is a popular one that they like also. Whenever the 2 clicks, whenever they are 3 clicks, whenever they are 4 clicks, then you should be able to get a more of a comparison. So when it was 1, so that's going to be now it is 2 times 8 plus 37.5 times 10 times the time always changes again. The time always changes. So you look at this one was saying 6. That's why I was confirming. Why am I seeming to have wrong data? So it says 6. So 6 divided by 6 divided by 60, and I have 1 over 10. Okay, that is my 1 over 10. You can always go with that. I believe the same thing. Mathematically speaking, it's not a math to write in this way. Then now we go to 3 times 8 plus 37 times 10 times. Then I believe the time is 4 minutes now from 6. Wait, no, I'm wrong. What is the original time? Oh, the original time is this 1 over 6. Oh, and then now 1 over 10. Okay, perfect. So we're going to 4 divided by 60 minutes, and we have 115. Okay, so that other one is going to be 121.15 times 8, and then the last one will be 4 times 8 plus 37.5 times 10 times 1 over 20. Everything else times 8 equals and then now we start with the typing your answers. Now we have 8 times, well, actually 8 plus 8 plus 37.5 times 10 times 1 over 6 close bracket times how many hours they work? 8 hours. Then that is 564. Then you edit this to a 10. Then you have 364. 364. No. There are now 2 customers. Cannot be 364. It's actually because there are 2 what you call clerks. This is that cashiers 428. You just edit. Three, 9, 2. Then the last one is 20. Now there are 4. Then the last one is 406. Look at the cost. Which one is less? It's this one. How less? Well, how many workers you have? You have 3. So if you hire 3 clerks, that's your original. Whereas when you have only 1, that's your price. So it costs more to have 1 because of you're losing customers. Yeah, when you keep the customers waiting for far too long, then that's the effect that is gonna affect you. Okay. Now we move right along. The Rock Electronics Corporation retains service crew to repair machine breakdowns that occur on an average of 3 per day, okay, and then the crew can service an average of 8 machines per day with a repair time that resembles the distribution. Okay, what is the utilization rate of the service time? So you don't need that. Another thing that is very critical, these, if when they are the same, it is possible. When the SI unit is the same, it is possible to continue. You don't need to now say divide by 24 hours and divide by 8 and so on and so on. No, you can work with this type of statement. What is the utilization rate of the system? Okay, so that is A. Okay, I need to go at the top, make a line here and make a solid line. Okay, it doesn't want to listen. Okay. So now A is probability of that over that is equals to, oh no, 3/8. The best way is to write it in a form of what? Of a percentage. 3 divided by 8 equals to that, and then multiplied by 100. Then it gives you 37.5%. Then what is the average? And that's when now reading is very critical. Reading to understand what is the average downtime. You can tell that we are talking about for a machine that is broken. We are speaking about time. Eh? So that is, we're speaking about time. B. So what is your average downtime for a machine that is broken? So a machine that is waiting to be serviced, basically. So that is going to be WQ equals to. Then you go to your formulas. You find the WQ formula. It's this. All right, and then 3/8, 8 minus 3. 3/8, 8 minus 3. Okay. Some fractions, they don't need you to really keep them. You can just do away with them. Then we have C. How many machines are waiting? LQ. They're not in the system, they're waiting to be serviced at any given time. So they are, I think this is a square here, and 3 square. 8 minus 3 equals to, you go and edit this. 9 over 40, that is 0.225 machines. Here, hours. Right. Then I'm starting to write below here now. D. Then this is what I like. Then this is where now it tells the probability that there's going to be something in the system. Probability that more than one machine is in the system. So you see that part. This is the part that I was talking about. Now it has arrived, which is a good thing. Probability that there is more than, so you answer as per the question. Probability that there's going to be more than one in the system, and then that is 3 over 8. You go straight to 1 plus 1 equals to, you multiply by 100 same time. Then you go to your 3 over 8, close bracket. Obviously 1 plus 1 is 2. Multiply by 100. There is a 14% chance that there's going to be one machine. Now you do this with another probability that more than 2 broken machines. Okay, so P N 2. Then you just go to and edit your answer. It becomes 2 plus 3. Okay, the best thing is to edit 100 there and there. Okay, immediately we're going down. Wow, equals to 0.74. Right. Then when there's Pn greater than 3, you go do that. Wait, my formula is incorrect. It's supposed to be 2 plus 1. That is a 5. So this, apologies, this is wrong here. It is a 5.27%. Then this one it's a 3. 1.98%. Pn greater than 4. You go to the same. So now I believe that people are able to see that we are given the statement 0.74. Okay. We are given the statement. Right, I'll make a line here. That will divide my work. Right, so from historical data, Henry Car Wash estimates that daily cars arrive at a rate of 10 per hour all day Saturday, with crew that working the wash line. Harry figures that cars can be cleaned at the rate of 1 every 5 minutes. You see, now we have two probabilities that are not equal. We have 10 per hour, and we have 5 where you are servicing 5 per minute. Servicing how many? 5 minutes, one car. So this is very interesting. Then the conversions now. We have 5 minutes per one car. You see that 5 minutes per one car. Firstly, the are not equal, and this is your average, your service time. Then you deal with this first. 5 over 60 equals to, you send it to hours again. 5 divided by 60, then we have 1 over 12. There's still hours per car. Then you can see that now we want hour per cars. So in an hour, we're going to have, we'll do the flip side, 12 cars per hour. And this becomes your that. The number one average number of cars in the line, average time of cars before it is washed, average times car spent in the service. You see now the difference. So it's very critical that you appreciate the terminologies, and the terminologies is what we are going to be asking every time. I would like to erase here. There's too much going on, and my Zoom doesn't correspond with. I need to do Zoom more because the space has gotten to be too small. All right. Now, I think I must reduce the thickness of the pen. Number A, we have number of cars waiting in the line, meaning LQ. Then, anyone who remembers, they will remember the formulas. The more we work with them, they stay. Then that is 10 as an arrival, and then that is 12 minus 10 equals 2. You come to your calculator, AC first, and then bracket, no bracket, fraction, 10 squared, 12 minus 10. Close bracket, and then answer 25 over that. I'd rather give it as 25 over 6, 25 over 6. Then B, we're looking for the average time car spends before it will be washed, waiting. Yeah? So that is your WQ equals to, that I believe is this. So they didn't ask the question as per the sequence of events or the sequence of the formulas. They asked it in any random way they feel like. So this is the type of questions I'll be setting also in a test. So 5 over 12, 5 over 12. Right, C, we have average time a car spends in the system. That is your W equals to, I believe this is 1 minus that, and then equals to 1. 12 minus 10 equals to 1/2 hours. Average time, okay, D, utilization. Now you're looking at utilization equals to 10/12. Five over 6, which is times 100. 83%. Then probability that there won't be any car, E, is 1 minus my answer is that. No, it cannot be negative. 10 divided by that's my answer times 100, which is going to be 16.67%. All right. So this is how we're doing them.
Sir,
Yebo.
can you please repeat how you found E?
All right. To find E, we say probability that there won't be anything in the system, and the formula goes like this. 1 minus that fraction, I will leave it as 10/12. I know it's 5 over something, but 10/5 is fine also. 10/12 is fine. It will lead to the same answer. And then that answer you see multiply by 100. 10. Let's pull it over. So times 100. Yeah, when this thing is thin, I feel like I'm holding, I don't know what type of a pen. Make it thicker again. Yeah, much better. Right, now you go to your calculator. 1 minus 10/12 equals to that times 100. But that becomes 16.67. So in simple terms, if this is 100%, therefore 100% minus 83.33, then you should be arriving at this. Okay. Then we have this long question. Mike Dreskin manages a large LA movie theater complex called Cinema 1, 2, 3, and 4. Each of the 4 auditoriums plays a different film. The schedule is set to that starting times are staggered to avoid large crowds that will occur if all 4 movies started at the same time. The theater has a single ticket booth. This is their machine, okay, and the cashier who can maintain an average service rate of 280 patrons. So that's a service rate. So per hour, then like going up there. Then that is 280. Then service times assume the following exponential distribution: arrivals on typical active day, Poisson distribution of average. So the arrival is 210. All right, per hour. Then Mike wishes to examine several queue operating characteristics. Find the number of moviegoers. The number of moviegoers waiting in line to purchase a ticket. That will be your L2. So I'll call my former colleague just now. No. Now the class is on there. When it's critical stage, I'll call my former colleague just after here. Getting a call from UJ. I'll call him. Shouldn't worry. Hey, they say it's serious when a person call you twice. Let's see. Dr. Chiron. Yes, sir. It's Apologies for that, guys. Ish, you know, old people. So we're gonna look for LQ. One thing I can assure you is that the formulas we tend to use formulas for the equation 1 to 7 and 13 to 18. So far, those are the equations that I've used. These other ones, I've never used them. So these other ones are decorative. But I'll give you all the formulas in a test. And then that becomes there. Okay. And 240 over no. Why am I getting the 240? 210 over 280 minus 210. Okay, then that becomes and it's a squared here. 210 squared 280 bracket 280 minus 210 close bracket 9 over 4. Moving right along, you go to the next question, which is the percentage. You see now, I like it when they put it like this. The percentage of time the cashier is busy. And then what is the average time that customer spends in the system? So B is the percentage, which is your P is equals to this over that times 100 equals to 210 over 280 multiplied by 100 equals to 0.4, 75%. Okay. Number C now. What is the average time spent waiting in the line to get a ticket? Okay, 1 over 280 minus 210 equals to, you go to your formula quickly, minus okay, we leave it as 170, 1 over 70, leave it like that. And you're looking for probability that they are, you see that there are more than 2 here in the system, more than 3, more than 4. So now we deliver for the sake of time, I'm gonna write it only once. Probability that there are more than 2 in the system, as you can see that they are heading straight for 2. Okay, equals.
Sir, but you jumped the Amos.
Did I? Oh. All right, thank you so much. Let's do the T. Okay, what is the average time spent waiting in the line? What is the average time that customer spends in the system? Okay, so you see, um, now I must go back to the formulas. What is the formula? W. Okay, W. This is W. This one. Yeah? The average uh, time spent in the system. That is this one. C. Yeah? What is
So
the average time?
on D, are we not looking for WQ?
Definitely. That's what I'm saying. Yeah. That's what I'm saying. That this one. Yeah. And then we have it like minus one. Minus not one, but minus that equals to 210 over 280 minus 210, which is which is 3 over this one. You can write it in a formula. Oh, okay. And this is our cycle. Then D now. Pn. This other go straight to the formula. K plus 1, which is 210, 280, 2 plus 1. Because I want it in the form of a percentage, rather you do this now and then 2 plus 1. Multiplied by 42.19%. Okay. And then the P, where Pn is greater than 3 is equals to, you just go to amend the top, make it as 3. .64, and where Pn is greater than 4 equals to, we go there, amend. But when you're looking for marks in a test, you do all of these things because you want to collect all the marks. And 23. 23% of the time there could be more than 4 customers. This is what it reads as. Okay. This question here is going to be the last one I think that I'll do, because it requires me to also do times 2. Requires me to do times 2 because it says here, if a second cashier is added who works at the same pace, who will operate the similar characteristics, redo everything that is at the top there. So now number 1, yeah, and also the thing I liked about this question is the fact that you have what do we have? I see 12 seconds. It's the single cashier, takes about 12 seconds per customer. Okay, but what is the original? Okay, the university cafeteria line in student center is self-service facility in which students select the food items they want and then form a single line to pay at the cashier. Students arrive at the rate of about 4 per minute. 4 per minute. So that is your student your arrival rate, and then this one now is your 12 seconds. It's your service time. So it takes the cashier 12 seconds to service, 12 seconds to service, 12 seconds to service one customer. So that is over 60, and then you convert. Conversions are very important. 12 divided by 60. Then you have 1/5. That is one customer per 5 minutes. So now we want per inverse of that. That would be 5 customers per minute. 1/5, and then 5/minute. These are in the same SI unit, therefore we are able to work with them. Then what is the probability? What is the probability that there are more than 2 students in the system? Probability that there are more than 2 students, probability that there are more than 2 students. You see that we start there equals to. You then gonna you remember the formula, I just did it now, and then this one is 4, that one is 5, and then 2 plus 1 multiplied by 100 equals to, go to your calculator, then 4/5, 2 plus 1. 51.2. What is expected number of students in the, no, why am I skipping stuff? This time of skipping is not good. B, what is the probability that the system is empty? That is your P0. You know that you cannot get the P0 without, okay, you don't need.
Can I ask?
You will, yes.
Lapago, what is the probability that there are more than 2 students in the system, right?
Or and then they continued more than 3 and then more than 4. Okay, you need to, yeah,
4.
until 4. Yes, you guys you'll do it until 4. Okay. So
Okay.
yeah, until 4 up. Yeah, so till PN. Okay, let me write till. So now, what is the probability that this the system is empty? So that is your P0, which is equals to 1 minus this. So you don't need to calculate it first. You can just somehow go straight to the answer, and you say 4/5 is equals to 1 minus 4/5. Then you have 1/5 as your answer. 1/5. So there's times where they ask about probability, but this one you must do it as a percentage. From the tables that we're dealing with, we were analyzing it as a percentage. So please, this one, do it as a percentage. This one for probability, you can wait until they say it's a percentage or not, and then see how long students have to wait. That is time before reaching the. So sometimes you'd find that it kind of confuses you. Like for instance, let's say how long, that is time, ne? They wait, ne? So that is not the time they spend in the system. Basically, it's how long. So they're waiting where in the queue, ne? So they're waiting on the queue. When you then you go read it will give you some idea. So now it says to you what is the expected number of students in the queue. So you can tell that, okay, here we're dealing with WQ also. And what is the average number average number in the system? Sometimes what is the average time in the system, you see. So if something confuses you, you go down and read others, and then you come back and address that one. You know exactly what they're looking for from there, right? Okay, for I think we are doing C, WQ, okay. WQ is equals to, what is the formula? It is the one, okay. So this is the one that doesn't have everything here. It's going to be 4, then 5 minus 4 equals 2. 4, 5 bracket 5 minus 4. If you guys do not have class after here, I would like to slightly push a little bit more, just slightly, especially to redo it here. Only this part to redo it, to do F. I wish to, because this is a test level. This is a test level, and also to announce the homework. Please do the homework. Please do the homework. Tell them in the group that they must do the homework, guys. Please. I do not want anyone failing this thing, so they better do their homework. We know how we roll. I'm not gonna repeat it again. What are we doing now? B, C, then C, then D. What is the number in the queue? All right, L Q, which is the one with the Q. So with the squared, 4, 5 minus 4 equals 2. You just edit that. Squared. Okay, and then we can write there 16/5. Okay, and then A, B, C, D, E. Wait, how long? No. What is the Q? Okay, the system average number. Okay, that is L equals to L. I believe L is 4, 5 minus 4. Okay, so you remove the squared there. What's happening? W, I was looking for WQ. Okay, all right, okay, so we do not have the 5 here. I could tell that why the formula is looking the same. Yeah, it's like this. Yeah, it's like this. So then that is 4. There are 4 customers in the system. Then F, we repeat with 2 caches, we repeat B, C, D, E. Ne? We repeat B, C, D, E because you can't. Then B, as you can see, that it requires that complicated formula. I didn't plan to repeat this. That's why maybe I have no space there. Yeah, okay. I need the space. It's very critical for me. All right. Then we have what? We're starting afresh to B. Then we know that B is P0 equals to. This is a very complex formula. You must write it in full. 1. We have N is equals to M minus 1, which is 2 minus 1, which is 1. Then you know where to start. So now the formula, I believe you should have it somewhere. You say 1 0 exclamation mark, and then 4/5 0 plus plus you repeat again the very same thing plus 1. See, this goes to 1 now. Then it's going to be 4/5, and then now it becomes 1. Close bracket plus. Then you do this, the rest of the formula. 1/2 exclamation mark. M is 2. Then 4/5. Then M there is 2. Minus, not minus, 2 multiplied by 5, and then 2 multiplied by 5 minus 4. So this is what you're going to write. And then as for status, you need to look for doesn't want the values that are here under this bracket. They're going to be 2 values that they are in summation. Then you look for the rest. So now you clear open bracket 1 0 shift. Wait, my calculator doesn't have exclamation mark or there. And then 4/5 close bracket 0. You need to learn this quickly. The first one is always 1. then 4 over 5. Then now the other stage now. 1 over 2 exclamation open bracket 4 over 5 the square, yes, times 2 times 5. 2 times 5 minus 4. Okay. When you see funny numbers, you must now start introducing bracket. I will tell you free of charge. Let's just put a bracket there. Yeah, gut feeling told me something's wrong. Then 8 over 5 is equals to. Now we have everything under 1 over 1 plus 4 over 8 plus 8 over 5. Then we have this depending 0, 3, 2, 3. Now like this. I like using it as a fraction because we need it in the next exercise. Take it as a fraction. Then now number B, we are looking for how is it C? How long will the average student have to wait? That is WQ. So the WQ, if you look at your formula sheets, you will realize that in order for you to get WQ, you must look for LQ. Waiting in the line. How long will average student have to wait before being yeah, that's not okay. Because if it's a waiting, okay, before that is WQ. So you need to do you must do all of them starting from. There's no shortcut. Starting from L, must look for L because L you use it for W. Then LQ you you must do everything. Must do everything. You don't have any choice. So right, and this is the additional time I needed from you guys. Okay, L. Then because I haven't been writing these formulas, the following ones I'll just write them. It says this. Okay, bracket and MP0 there. Then you come back and say M minus 1. Do not forget the exclamation. M that minus that. Then there's the last section that we add plus. Then now we're dealing with 4 and 5, right? 4 multiplied by 5 over 4 over 5 M2. Okay, then 2 minus 1 exclamation mark 2 multiplied by 5 minus 4. I hope I don't have a 3 anyway. I used I have a feeling that I might have used a 3 that I shouldn't be using. right? And then that is 10 over 31. 10 over 31 plus that, it's your 4 over 5. Okay, I believe this can go in a calculator all at once. We have that 4 times 5, open bracket, 4 divided by 5, close bracket, square. Then we have 2 minus 1, exclamation, and we have 2 times 5 minus 4, close that, and then multiply by my new 31 plus 4 over 5, and I have it as 1.488. 1.488. I need to just double check something. So when you start to write so many formulas, and yeah, you need to bring back the confidence by making sure that you're not making any mistakes yourself also. So this one chapter is this, chapter 3, 9, 10, 11, chapter is 15, 13. Okay. Oh, this is 14 here in the book. 17. Just need to confirm my answers before I move along so that I do not make any mistakes. So, okay. 14 point, 13 point, which question are we in? 14, ne? 14, yes. Twelve, 14. Minus 4. 1 over 2.33, 0.429. Then what is my okay, I need to make sure that what I'm doing is correct. I want to confirm this. 10 divided by 81. 0.33. Okay. 4 over 5. Okay. Yeah, this one is a little bit incorrect. So let's go to check it out. Okay. I need my formula just to make sure everything is good. 1 over 2, 4 over 5 to the power m multiplied by me see if I say that. Over 5. Okay, gonna write it as an 18 over 15 like this. Eight over 15, okay. Nine. Why am I not getting the right answer still? What's wrong? Guys, I need to make sure that I can at least give you the right answer. Okay, let's go to one. Okay. Let's see. Okay, this one they made it as a 10. I have to get this one right. Okay, it's 8 over 15. Okay. No, there's no other way it could be proven otherwise. It means that this is right. Plus 4 over 5. Okay. Plus 8 over 15. 3 over 7. Yeah. I don't know. Depend. Yeah. Now I'm getting the right answer. This is right. Which is 3 over 7. 3 over 7. You must explore the use of your calculator carefully, guys. The use of your calculator. And luckily I didn't go too far with my answers. So then 4 times 5, open bracket, 4 divided by 5, close that, squared, and then 2 minus 1, close bracket, that, and then open bracket, you have 2, let's write it as a 10 minus 4, then squared, then times 3 over 7 times, this is plus 4 over 5. Then we have it as a 0.952 for argument's sake. Then now I believe the formulas are going to be shorter. Now we are looking for what W equals to. Now we're looking for W, which is equals to L over this, yeah? And which is 0.952 over 4. Yes, the hand. It's the hand or it's text. Yes, you can talk. Okay, I don't see anyone talking. Then that answer divided by 4, which is your divide by 4, then you get 5 over 21. 5 over 21. Then now we're going to look for LQ from there. Ivo,
Morning. In
yes,
the previous answer that we just got, below
yeah,
the divider in the second bracket, in the calculator you square it. Why are we squaring it, sir?
let's look the formula. There's a square there. W is equals to, there's a square. There's a square. If I left it out, it's a mistake. There's a square. I go when I punch in, I look at the formula sheet on the hand. There's a square. Apologies for that. I did left it out. But there is a square. Apologies for that.
Thank you.
Yeah. And now we have this LQ minus that over this, which is equals to 5 over 2, 1 minus, minus 4 over 5. So now the answer, I'm going to press, why my mouse disappearing? My answer, this, which is this, minus 4 divided by 5. Why it becomes negative now? L 5 over 21, which is L, right? No. Oh, L, this is L here. Yeah, 0.952 minus 4 over 5. Then the answer is that. So I need to fix this. It's L, remember? So 952 minus that. Then your answer becomes equals to, then your answer becomes this 0.152. Then only now you can look for the WQ, because the question says you need to find what is the average, how long will the average student have to wait before reaching the cashier. So that is WQ. It's forcing you to calculate everything. Yeah, which is clever. So it's forcing you to calculate everything. Now WQ is equals to W. I didn't need to calculate everything because there's a formula for W. I should have just taken the W there, this one. But still, yeah, I should have just taken the W instead of doing the Q first. So the W is equals to 5 over 21 minus 1 over 5, which is 521 minus 1 over. Here, if you want to be safe, leave the fractions, the simple, straightforward fraction alone, and you work with them as they are. Then the answer is 0. And the answer for WQ is 0.38. Okay. Okay, then they've
Sir,
able.
can you please under the instructions when other question, can you please indicate how we should round off, because on the previous questions we were rounding off to the 2 decimal places, then on this one we are now rounding to 3 decimal places.
Okay, I'll keep that in mind. If stated otherwise, let's stick to 3. Ne? Unless stated otherwise, let's stick to 3. Yes, 3 is safer. It can maintain that level of accuracy as we are working around.
Even on the previous questions.
Yeah, you can do 3. But then only the final answer. Like this one. Remember this one, you're looking for what first? You're looking for P0. From the P0, you take it all the way to WQ. So you start there at P0. So on my case, you can also combine the formulas. As you can see, it says we are looking for what? WQ again. It says W minus that. So the W formula, where is it? Is L over that. Then you can take this whole formula and put it here, but you don't want that. Splitting it is it's a safe approach. And luckily, this is even correct according to their thing here. So yeah, this is 100% correct. And once you got that, obviously we did the Q. So you just label the other ones that you are supposed to find. So because we found everything, you then say, okay, what is the expected number of students in the queue and also in the line? So you see that this one, it's already been found. It helped us to find WQ, né? It has to help us to find WQ, but it's also one of the things that they asked in the test. So you can just somewhere come and label it here. It's D, yeah, D and E. You come D, you label it nicely. This one is D, and this one is the one for LQ. It's E. For the one for LQ, it's E. Then you're able to label them, because you cannot repeat them just because of you didn't answer them accurately as per the sequence. Then you can just label them like that. Yeah. So now the homework, ladies and gentlemen. Remember, I am very particular with my homeworks. They're saying this thing can be done in the software QM for Windows. I don't have time to demonstrate that because it doesn't really assist us with anything at this moment. But for study purposes, yes, you feel free to use the software to help you analyze. And then they use AI also to critique. So AI can solve a lot of our equations. Just to see a different point of view, copy and paste to AI. So this homework is very important. 13.24, please do it. I'm not going to announce it, but you know how we roll. Please do the homework. There is 13.24, and another one is, oh, actually, it's the old one. Oh, okay, interesting. I thought I had so many homeworks. Oh, there's another one. 13.17. 13.17, you must do these 2 homeworks before next week, Friday. You must do these homeworks, please, guys. I beg you. We are going to do theory calculations only, no theory in the test. And yeah, all the best. Thank you so much. See you on Friday and when you consult. So how are we going to handle the consultations? Okay, there's so many stuff happening. Yes, talk to me.
Say,
Talk to me.
You?
One at a time.
I was. Oh, Joe.
Talk, Mren. I lost this guy.
Okay,
Say,
so
I was
you,
asking. So
you.
my question is not. Oh,
Mren, give the lady a chance now. Give this lady a chance, yeah. My sister, let's talk.
So I was asking about the formulas. You said you're going to give us all the formulas, but then
Yes.
for practicing purposes, we can focus on only on 1 to 7 and 13 to 18. Is that what you said?
Yeah. I can do my homework.
Okay, thank you.
Actually, do my homework. Yeah. Oh, I don't want to throw the obvious hints, guys. When I say do my homework, I mean it. If you haven't learned your lesson, you will know how I work next week. Do your homework as a first priority and master it if possible. As a first priority, do my homework, then practice. You can practice everything if you want to. The whole book examples, you're using both AI and the software to answer for you. And then uh, just a quick one on the software. I know students tend to struggle to find this thing or where it is. Uh, I also struggle sometimes. You see the weighted in lines here, waiting lines, waiting in lines, and then you just read nicely there. Uh, Usually we're doing the exponential and no cost. If you needed cost, if it has cost, then you can say cost. If then no cost, then it will appear like this: exponential service time, arrival rate, service time, rate, number of services, and you work just like that. It will give you the stuff that you wanna do. All right. So the gentleman, can you now talk, sir? Talk to me, Rafiu.
oh, thank you, sir. My question is not based on what you were teaching us now. It's based on the assignment. I was asking if we should also submit the QM that we did, or we just pasting it on the Word, then we submit.
Just pasting it on Word. Just
Pardon?
paste it on Word.
Or paste it on.
Paste it on Word. Yeah, yeah, yeah. The results, yes.
All right. Thank you, sir. That was my question.
Yeah, and then I'm going to be available until let's say until around about 2. I'm going to be available in my office now. Those who want to see me, you can just tell them in the group that I'm going to be available. I think I will from now on find a way to announce whenever I'm available in class. Whenever I'm available in my office, I'll try to announce, and then also we will use our periods for the purpose of consultations. So Monday, or it's only Monday. I no. I think just send me emails soon. But Monday, I will be available to take a consultation within your period, which is 8, 10 to 12. So you can just, if you want me to see you face to face, I can avail myself in campus. I don't have a problem. However, on these other days, you can just anytime send an email or through Vutela, send a message. I'll try to respond. Yeah, I think that's all on my side. Do my homework. I do not want to. You do not want to fail this coming test. It's going to be fairly easy, but you should make sure that you prepare yourself and focus more on the homework that I gave you, the 2 homeworks that I gave you as a first priority. Agree going to practice using the book, well, not the problems, but the examples. Then the first thing first you do is the homework. You write it down and you'll submit it when we meet next term. Then you submit the homework. Right, guys? Is there any further questions? Okay.